I would like to start with giving you a little bit more guidance on lab number 2, especially figuring out the types for the generics. The reason I want to talk about this in detail is refer to this part of the recording later when you get to a lab test preparation. This will be something similar to what you will be given in the lab test, which means I give you something that doesn't really compile. So what you should know very for sure is a systematic way of figuring out what to put for the generics, okay? Which is going to be very beneficial to you, not to program in IFO, but also in Java. Okay, so now let's have a look at the classes over here. I try to put all the relevant classes over here in one single page, simplified version, of course. And let's go over the things we know and the things that have been colored over here, they should be filled in. And then I will tell you one way to figure out. You can try to practice as well for your actual lab number 2. Okay, let's see. First of all, let me just use maybe normal line to show you the classes we had to look at. We start with the database class, okay, and then we got V1, V2, and K. We got 3 generic parameters. One thing to note, I'm going to point out some common error for you in just a moment. The fact that we declare at the database class level V1, V2, and K, so these 3 names are the only names you can use for generic parameter. You cannot create any type inside a class in order to use it. For example, I'll point to you a very common error right away, and that has been also answered in the forum as well. If I simply just put G over here, would it compile? No, it wouldn't compile. The reason is very simple, okay? If you want to have a class, this is how exactly IFO compiler will check it. First of all, G is not a known class name. It's not really part of the compilation, the compile classes. So G must be a generic parameter name. In this case, it is not V1, it is not V2, it is not K. So G is not known. Okay, that's a compilation error. Okay, that's one thing to note. Okay, I'll point out a second common error in just a moment when we get there. Okay, so we got V1, V2, and K, and also we got iterable, and then over here we'll figure this out in just a moment. Okay, what to put inside the iterable. And also we have a new cursor feature that we must implement since we inherit from iterable, and this is something we have to figure out as well. And the reason that I'm using the same color, hopefully you can see the intuition, they must match. Okay, the intuition is the type over here for the orange over here. The orange type I put over here simply tells you if there's a client for the database class, if they want to say across some dictionary object D, for example, as some cursor, what would cursor the item return? Is exactly the orange type over here, which means every element, but the client is going to retrieve the database elements one by one. What's going to be the type for each element? It's exactly specified by the orange part. Okay, but we'll get there in just a moment. At the moment, we just cannot tell just yet. Okay, it has to depend on what the clients want, and we'll get there. Okay, after this, let's look at some classes that's already in the library. So we have a class called iterable. Okay, we also have a class called iteration cursor. So these are just part of the architecture that I showed to you, right, for the iterator pattern. One thing to note, you can see that we have consistent use of the generic parameter G over here. So G here just happens to be the parameter name that has been chosen for this particular class. You can see that over here, iteration cursor has just the same G. So what does that mean? That means as soon as we instantiate this G to be something, this G over here will be instantiated accordingly. Okay, so we always instantiate the generic parameter at the top level. For example, we can say iterable of string. In this case, G is instantiated as a string. That means every occurrence of G inside this class over here is also instantiated into string accordingly. Okay, we'll see some application of that in just a moment. Okay, after this, let's look at iteration cursor, similar idea. Okay, and then you can see G here and G here. One thing to note, let's say if iterable is something you wrote, would it make a difference if I simply say, I don't want G over here, I simply want, let's say, a different name. For example, if you are really used to Java programming, you might say E over here, and then I put E over here. Do you see any problem with that? No, that's okay. First of all, number one, E does not clash with any of the known classes. Number two, as long as I'm using E consistently throughout this particular class, I'm okay. It's just that for the convention for IFO, they choose G, H, and I. For iPhone, maybe E, G, etc. Right? Doesn't really matter the name for the parameter. But I'm just gonna undo. Okay, let's just go back to G over here. Okay, so now we have done with these three classes on the left-hand side. Let's look at one more class before we see the clients. So now we also have one class, let's say my cursor. So like case number 2, you have to implement the iteration cursor by yourself. And then over here, for the generic parameter over here, I also leave it in just a moment, okay? I use a different color purple here for a purpose, okay? We'll do that in the last step, okay? And then it inherits from iteration cursor, and this part over here, and then this part over here has the same color. That means once we decide what one orange color should be, all the rest should just be the same. Okay, but how do we figure out exactly what the orange type is? That's the issue, right? So the way to figure that out is by looking at the client code. Okay, let's look at the client code. So here I just have a simplified version of your example database test. Let's say we have a class called database user over here. Let me use green. We have database user here, and then we have D here, and then we have database, and we have matrix, account, and integer. Okay? Hopefully you can very easily see that as soon as we got matrix over here for this particular D variable, that means V1 has been replaced by matrix, right? And also account is replacing over here, and integer, the key, is replacing this. Okay, just a aside. Okay. Now let's see exactly how we can figure out the orange part. Let's see this particular feature, traverse all, which simply just want to go over all the elements in this particular database. Okay. Let's say eventually what I can do is over here. Let's say I have a local variable here, records. Okay. And then I say that it's simply going to be a linked list of something. Okay, I'll leave that as orange as well, right? It's up to the clients what they want to retrieve. And then I just create the records initially, and also I use a cross loop over here. Across the D, I can do that simply because D of type database is iterable. That's why I can use a cross loop. Okay, first of all, if you don't have the inherent iterable, you cannot use the cross loop. And then we have as cursor. And there's one important thing you want to notice. As I mentioned last time, when you say across an iterable object as some cursor, so this is something implicitly Ivan will do for you, which is as follows. I'll write it down explicitly for you. So over here, you can see that the cursor over here basically is like this. You know what? I will try to put it over here aside, okay? It's basically saying cursor is just assigned to D, which is iterable, which is guaranteed to have the new cursor feature. New cursor. Okay, that's kind of implicit. You don't have to do that explicitly by yourself. Okay? That's really a key step. So that means we are going to use so whenever we say cursor.item, and it's going to tell you exactly what the type is for the item, right? So let's look at the next line. And also here you can see records.extend to the linked list, and then we say cursor.item, right? You can see once we figure out exactly what a cursor.item's type is, we can actually figure this out, right? Okay. So now, what should that be here? In your lab number 2, how many different cases did I give to you? I think I give you maybe about 1 or 2 different cases, right? It can either be a record or it can be a tuple, right? So now, let's just choose something arbitrary. How about that? Okay, just as an example. So the only thing, so we start with, first of all here, so I put a number here. So that's the order of looking at the things. Step number 1, we know that cursor.item is going to depend on what a type it is for the records, right? Because the record is going to be a linked list of something, like orange, right? Okay, so now let's look at this line here. This is the only thing that we have to decide, okay? So now let me say, for the sake of example, let me just put in blue over here. Let's say linked list of, let me say tuple. And let me just save my writing, I'll just say T. Tuple of, let's say, I would say integer, account, integer, matrix, and account. Okay, I'll start from there. So this is something that will be given to you, like in your example test. From here, we're going to figure out exactly how things will go. Okay? Actually, we're pretty much done, right? Basically, well, once you see the whole picture, everything together, it's basically done. Can I simply put, well, you can see this is orange. This is also orange, right? Can I simply put something like this? T of integer matrix and A. Well, I'm being naive, right? Because that's orange. I'm just copying orange to orange, right? Can I actually do that? Yeah. I tell you what the problem is. If you do this one, I'm not sure about compilation. I'm just telling you conceptually it's wrong. If you simply say T integer matrix and account simply because I got that orange part in step number 1, step number 2 over there, right? The problem is you're saying that for this particular database, it's always going to return each item being integer, matrix, and account. It's not going to make any difference, which means whatever the client instantiate V1, V2, and K, actually, it doesn't really matter. So now, let me give you even more explicit. Let's say I change my mind this time. If I say D2 over here, okay, I would say database, okay, just say D for short. Now, this time, I will go back to your lab number 2. I will say string, character, and integer. And now the hilarious thing would be, if I try to say across D2 as cursor, what would be the type for cursor the item? Would it be simply a tuple of maybe string, character, integer? Or it would simply be a integer matrix account? It would be an integer matrix account because remember the new, okay, let me just say that again, okay? In case you have lost. Let me recap. It's very important. Basically, I'm trying to explain to you. First of all, the client simply wants each item, in this particular case for D, each item type to be integer, matrix, and account. Okay? For this particular D example. Now, in this case, I ask you if I can simply just copy and paste this guy here to here under iterable. The answer is no, you cannot do that. The short answer for no is you're going to make your database too restrictive. That means every time, doesn't matter how the client is going to instantiate V1, V2, and K into, you always return integer, matrix, and account. Always the case. Okay? For example, let's say over here, for D2 over here, if you get another database with string, character, integer, like what you did for lab number 2. In that case, if I say D2 dot new cursor, what's going to be the type? Well, the type for the new cursor is going to be exactly the same as the iterable. Okay, so that means it's just going to be integer, it's going to be a matrix and account. Okay, that's the reason you cannot do it. Now, what should we do? Okay, here comes the critical part. Okay, so let me just tell you exactly what you should do. So let me just tell you this is not the right thing to do. But this is very important information over here. Let's go back here. We know that when we say matrix actually instantiates V1, agree? V1 over here. And accounts instantiates V2. And integer instantiates K. That's kind of the information we want. Because if you want to program backwards into the generic class, you better generalize what's happening in the client side. Okay? On the client side, even though we see that the concrete example for D is matrix, account, and integer, but the client is basically telling you, you should say V1 followed by V2 followed by K. Okay, so what you should have put is something like this. So this is not right. You would say tuple, and then V1 followed by V2 followed by K. Okay, that's what you should do. Okay, everybody follow? Actually, let me go back there. I said something wrong. Let me do it again. I want you to compare matrix corresponds to this matrix here, right? Agree? And the account corresponds to this account over here. Okay? And then the integer corresponds to this integer here. That means the order is actually different. That's exactly what I wanted to show. Okay, so let me tell you what the final answer is. You should put tuple of K, V1, and V2. The reason, again, let me just try to say one more time. Okay, so you can see that for the database, whenever you for D, whenever you talk about matrix, you talk about V1 basically. Whenever you talk about account, you talk about V2. Whenever you talk about integer, you talk about the key. Okay? So now for the client type, that's in that case they put integer first, which is the key. So that's why we put K first. And the second one is matrix, which is V1. That's why we put V1 over here. Okay? For the third one is account. In this case, account is V2. So that's why we put V2 over here. So this is a general thing that we can put back into the database, iterable. So what we should put over here is something like this. So now, rather than this, we're going to put tuple of, you're going to put K, V1, and V2. So you can see that over here, even though we say V1, V2, and K, it doesn't have to be K, it can be a different order for the iterable, right? That's exactly the point. There's no binding power to say you must follow the same order. And I did this intentionally to let you learn the lesson. But since I now make it explicit to you, hopefully you can learn from that. Okay, once we figure this out, every orange over here can be replaced by that. Okay, let's see. So now let me, over here, so you can see this orange over here. Let me just put it first, and then you can tell me, let me just finish this, and then you can ask your question. Over here, I'm simply copy and paste over here tuple of K, V1, and V2. And over here, I'm going to put also tuple of K, V1, and V2. So things will just be consistent right now. However, look at the class for my cursor. Would it compile at the moment? Is there any missing part? What about the purple over there? You can see step number 6. Did we fill in anything there? You can see over here in this iteration cursor clause over here, we are saying that we're going to use K, V1, and V2. For the item feature, we're going to use K, V1, and V2. Agree? But we didn't mention anything here. But we're going to declare them, right? So basically, we kind of work backwards. We talk about usage of those 3 necessary parameters. Since we need to use them, so we declare them in the class level. So now, question for you. Does it really matter about the order of K, V1, and V2 in the class level? My question is like this. Now for the purple part over here, I would say K, V1, V2, first possibility. Or I can say V1, V2, and K. Does it really matter? I would say it doesn't matter, shouldn't matter, as long as you're using that consistently. What do I mean? Okay, let me be more precise here. Let's say if I happen to choose this option here, K, V1, and V2, that would mean over here, oh, of course, by the way, this orange here should also be tuple of K, V1, and V2, right? Let me just put it down first. Okay, so now remember, if you look at the slides, we also can declare some local variable here to be my cursor. Something like that. I'll say C of type my cursor. And this is where you have to maintain that consistency, right? Because let's say if I choose option number 1, I'm choosing K followed by V1 followed by V2. In that case, I better put K, V1, and V2 over here, right? That will be consistent. What if I choose the second one? If I choose the second one, V1 followed by V2 followed by K, what should I change accordingly? What I would do is I would say over here, I still declare my cursor, so I would say V1, V2, and K over here, right? So that's kind of the consistency you have to maintain. Okay, that's the whole story. I'll take your questions. Okay, so do look into this. I think that's really at least one way to figure out exactly how the types should work. In case you figure this out, but not very systematic like this, you would maybe just guessing. Because if V1, V2, K doesn't really work, you just try K, V1, and V2 work. So you don't want to really do that way. That's not the way to go for the lab test. I'm pretty sure I'll give you something maybe trickier for the lab test, right? So you really want to understand exactly what's going on here. Okay? Okay, guys, any questions before yeah, yes, go ahead.
For the inherit part.
Yes, which class? Database?
The database, yeah.
Okay.
We're going to have to match the class interval, right? The type.
Yes.
For example, if the class interval starts with the same type as the interval, we're not going to have a problem, right?
You mean, okay, for iterable, okay, the tuple over here, so this one here is completely determined by the tuple that we talk about over here, right? Because we want to see from the client side what the client expects to use this particular database, and then we program accordingly. That's the thing, right? So guys, I think let me emphasize just one more point. When you try to reiterate this particular example, the only thing that's predetermined for you is this particular linked list type. Pretty much your let number 2, because I gave that type to you, either a record or a tuple, right? With some fixed order of the parameters. So this is something the client decides for you. You as a supplier, you have to program accordingly. Okay? Let me see just one more since I just came to my mind. So another common error, okay? If you say iterable here, right? Let me just write it here. Would it be right if you say iterable? Okay, let's say I follow exactly this order here, K, V1, and V2, but I simply put K, V1, and V2. Would it compile? Why would it not compile though?
Because the whole is taking one parameter, generic parameter.
Aha, exactly. You can see over here, I'm passing 3 parameters over here. However, iterable only takes 1. That's why we try to wrap those 3 inside the tuple, right? That's why. That's the second common error, okay? First common error, you just put maybe G, which doesn't exist. Second common error, you put 3, whereas you should only put 1. You should wrap them into a tuple. Yeah? Oh, when I say lab test, I'm talking about what's going to happen in the second last week. The programming test, that's what I'm talking about, okay? But you may want to review this as well. I'm saying that's also relevant, right? Since it's already covered in the lab 2, okay? But don't worry, for the midterm, that's going to happen after the reading week. I will discuss with Professor Jang from Section E about which topics we're going to cover for both sections. So don't worry, we'll be very precise. Yeah. Yeah. Yeah.
So for the iterable in the database class,
Yeah.
For the tuple, it's actually set by the client.
Yes, correct. Yeah, correct. So remember, first of all, we are given this by the clients, and then we work out it should be V1 followed by V2. Oh, sorry, let me say it again. We are given this by the clients over here, and then we figure out that should be the order of K followed by V1 followed by V2. And then we just basically apply the same ordering back to the supplier. So you always look at the client's codes to see what the expectation is. Remember what I said in the TDD lecture. Test cases are simply documentation for what's expected. That's another example. Yes?
Professor, what if the client makes another class but decides to swap around the V1, V2, and K and use the same supplier class?
That wouldn't compile, okay? Well, the question was something like this. Let's say this, okay? Let me just put the same clients, how about that, okay? Let's say we have just the same clients, and then somehow the client decide to do the following, okay? I'll try not to pollute the diagram too much, so I will only mention in this small box over here, okay? Can we assume that we still got this D over here, the same decoration as before, just D. And then over here, I'm going to change the types for the records, okay? So I'll put RS for records over here. It's still going to be a linked list. However, inside the linked list, I'm going to put something that's different, okay? What I'm going to put is, I'm going to put tuple, let me just do it again. Okay, linked list, which will take some generic parameter, and then I will simply say it's a tuple of something, right? Okay, let's say rather than integer, matrix, and account, let's see what happens. If I say matrix, integer, and account, that's what I say as a client, okay? Now, first of all, do you think, well, maybe I shouldn't ask you compilation, probably you should try that by yourself. Let me just tell you that. What's the consequence of doing this if you apply the same reasoning? The consequence of this is as follows. Okay? Over here, you can see that I can tell you that it will still compile. It's okay. But this is a consequence which you should know. Okay? The consequence is like this. We look at this tuple type over here, and then as we learn over here, matrix is V1. So I'll put V1 over here. And the integer over here is the key, followed by K, right? And then what is that? A is account, which is V2. Okay? So far so good? So that means you have two options right now. Either you have to go back to the supplier over here and then change this to be the following. Change that to be V1, K, and V2. And then make sure you change every occurrence of that. In that case, things will just compile. However, if you don't do it, you still keep just the way it is. Like I still have K, V1, and V2. Things wouldn't compile. You get some inconsistency here. Let me just repeat one more time, okay? You really got to think about this. The question was, what if the client decided to change the type for this orange here, for the linked list, okay? We simply do a linked list of tuple with matrix, which is V1, with integer, which is key, and also with account, which is V2. Okay, so now we got two options here, okay? For you as a supplier, if you want to make everything still compile, you have to fix the order of the tuple, right? So that means you got to go back to where the iterable is, for example. Rather than K, V1, and V2, you're going to fix them into V1, K, and then V2. That's what you got to fix, okay? And fix that for every occurrence of the orange. That's what you should do, okay? That's option number one. Option number two, if you just keep the way it is, it's not going to compile. Okay, guys, think about this and do try this in IFO compiler. You know, again, this kind of instantiating the generic parameter issue is not just specific to IFO. IFO is just one language that supports such feature. You can feel free to try the Java version if you like. Okay, the idea is really the same. Okay. Okay, question.
So do you have any tests for any post conditions in database from queries?
The question is, will I test your post conditions? Oh, you mean you have to? Do you have to do any testing for your post condition?
No, I mean, because of the post conditions, the queries, it's attributes.
Private.
We can't use it.
Oh, for lab number two. Okay, for lab number two, here's I kind of relaxed the rule for you. For lab number one, I said for all the contracts, you must only refer to public queries, right? That's for lab number one, okay? For lab number two, since I didn't say that you cannot use it, so for lab number two, yes, you can. You can refer to them. It'll be easier for you to write a contract, so that's why I relaxed the constraint for you, okay? Okay, guys, any question more about this issue here? Hopefully that will help you on completing lab number two. We still do lab number two tomorrow for the lab session, okay? If you want to ask the TA, or you can drop by my office hour. Okay, if no more questions, I'll continue with the topic for the singleton pattern. Okay, and then we'll do some inheritance after that. Big topic. Okay. So what we did last time, we introduced the idea about the once feature. Okay, once versus do. Let me recap very quickly, and then we'll just do. I wouldn't repeat this example again. You can just refer to the lecture recording or the slides. Let me just say them quickly again. So we have a feature called new once array. It simply uses once. So what that means is the very first time you call this particular feature, it is going to execute the body of the feature and then somehow store the return value, which is result, somewhere. Okay? For the second time, for the third time, for any later call to the same feature, you are not going to execute the body of the feature anymore. You're simply going to return that safe value. Right? That's why it's called once. You only execute the body of the feature once. So we want to know exactly how this particular once feature can be useful for our singleton pattern, right? So now, maybe I hope this will help you understand a little bit. How do you do the once feature in Java? Let me ask you, if you think you're good in Java. It's possible, but how would you do it? Just sketch some idea. Okay, okay. Yeah, you try first. Yes.
I'm not sure at all, but I picture an integer called count.
Okay.
And it's zero at first, but when I call it, it goes to one. If it's one, it doesn't run. If it's zero, it's one.
Okay, or basically that's right. Or we can just have a Boolean attribute, right? So you'll be initially false. As soon as I called it for the first time, it becomes true. The same idea. Okay, what should it be static or non-static for the attribute? Should be static, right? Because every time if I try to call that method there, you will actually change the attribute, right? Accordingly. Okay, good. Let me show you very quickly about the Java code. And I do have one criticism about it, and then we'll move on to iPhone. How about that? Okay, let's go to Java code. Let me just go there. Okay, you can read about the description for once routine. I'll leave them to you. I already illustrated the effects for once routine last time. So let me look at the, okay, in Java, right? Okay, good. Let's talk about the bank example. Let's say we have a normal class called bank data. So this is where the singleton should happen. We want to make sure there's only one single instance for the bank data to be shared among all the accounts. We don't want any duplicates, okay? So we got bank data here, and then we got interest rate, we'll set interest rate, for example. We got other information as well. Second class, let's say we got bank data access. Okay, so now we're separating between the data and its access, right? We talk about the separation of the two concerns. Now let's study this carefully. That's a critical class. First attribute, like what you said before, I'm just using a Boolean attribute. Initially, I haven't really called that feature yet, so just false. As soon as I call that for the very first time, I'll set it to be true. And then I got also static, also bank data, right? So you can see this bank data over here is just private. I should have said private, but it doesn't matter, okay? Just the data. So now this is what the client is supposed to call, right? Whenever the client says get data, okay? When they say the very first time, when they call get data for the very first time, that means init once will still be false initially, right? In that case, I will initialize the data for just once, and then set the Boolean value to be true, all right? And then I just return the data. What about for the second time I call this get data? In which case, init once will be true, not true will be false, so that means I bypass this whole if branch and just return the data directly. That has been initialized already, okay? Is it clear? Just about simple Java code. So now I have account over here. So you can see the way I get the data is simply by using static. So I can say bank data access.get data, right? That's how I get the data. So now, any problem for this? Is it possible for the account, who is the client, to break the singleton? So here, what we want to maintain is, we want to make sure there's only one single instance for the data. Is this Java code going to make sure it's always the case? Well, how about this? I'll give you a little bit hints. You can see under the constructor for account, right? Every time when I create a new object for account, right? What it will do is, it will simply just call the get data. For the very first bank object I create, you will execute the body of the if over there, and then initialize the very first objects. The second bank object, the second account object I create, is going to call bank data access.get data again, but this time, since that static Boolean attribute has been set to true already, so I will simply just return whatever data that has been created for the first time, right? Now, do you see any problem here? Is it still possible for me to have multiple instances of the data? Is it still possible? Well, it's quite obvious, right? It's possible, right? Okay, how?
Like you have bank data, data 2, and another variable.
Yeah, exactly. Let me show you one example. Not exactly what you described, but same idea. What about this? If I change the account constructor to be something like this, I say data, rather than getting from the bank data access, I simply say new bank data. Would it compile? Let's assume they're in the same package, okay? They will compile, right? That's a problem. So that means somehow the way Java works, it wouldn't really allow you to say, for this particular constructor, only certain class can call that, okay? Maybe it's because maybe for implementation, this may not be an issue, but for design, we want to make sure this is clear, Okay. So this is exactly the criticism I will have, but hopefully this Java code can show you roughly how the once routine also work. For the once routine, that's okay. I'm just saying for this particular implementation, it does not guarantee singleton. It does not. Okay? So what we should really support in addition to this is to say the constructor for bank data, which is here, this constructor here is only allowed for the bank data access to call. That's what we want to say, okay? But not any class else, okay? Now in IFO, as you have seen already in lab number 1, you got curly brackets beside the feature and say none, right? It's something called export status to say which class can actually call this particular feature. When you put none, it's really the extreme case. No classes may call this particular feature. That's like a private in Java. But IFO as a design language supports something that's very flexible. You can put any class over there. Okay? Let's see exactly how this might work. Okay? Let me show you. Okay, so now I'm going to show you exactly how we can implement this singleton pattern in IFO. And the idea is pretty much the same, like a once routine that we talk about, like how the Java code works. But there's some additional feature details I want to point out to you to make sure only the bank data access class can call the constructor for the bank data. Okay, that's the main thing. Yes, you okay? Okay, good. Okay, let's see one example here. Let's use the, I will come back to the bank data example as the second example. Let's use the first one, which is easier for you to see. Yes?
Can you use bank data, like internal class of bank data access?
Yeah, I'm not too sure about internal classes. Let me think about it. Yeah, if I just give you a random answer, it may not be so, yeah, reasonable. So let me think about it, internal classes. Okay. The question was, can I make maybe bank data as an internal class as a bank data access? You know what? I got an intuition you cannot. Because that means when I declare data over here for the account, that wouldn't be visible, right? It should still be visible as a type. It's just that when you want to get a data, it should only be through the bank data access. But how do you do it in Java though?
You set the constructor to private.
But if you set it to be private, that means the account, that means even the bank data access class cannot call that, right? Because if you set the, okay, the suggestion was, what if we simply say, let's go back to Java code here. What if I simply declare this bank data constructor to be private, right? But the problem is, no other classes, including the bank data access, can even call that. So this line here will not even compile. Yeah, maybe show me your Java code, and we'll decide if that works or not. How about that? My intuition is maybe there's no way around. Okay, maybe prove I'm wrong offline. Okay, okay. Let's now look at the IFO code. Okay, idea is pretty much there. We just want to go through some detail together with you. I'll use 2 examples. Okay, so now we have again we got 3 classes over here. Let me highlight them. We got data itself. Also, we got data access. Okay, so 2 separate concerns. And also, we got the clients. Okay. Now, I want to highlight right away to you. You can see curly brackets, curly brackets, curly brackets, and curly brackets, right? Over here. And the fact that we declare inside, we say data access. So what does that mean? That means 2 things. Okay. The first one, after create, remember create in IFO is to declare which one can be a constructor, right? Which features. Now we are saying that only data access over here, the class, only inside this class can we call make as a constructor. That's what it says. Okay? Let me show you one thing right away. Okay? So now this is exactly the sample code. I'll make it available to you. You can also try that. So we got share data over here. You can see create. After create, I simply say only share data access can call the make. Let me try to call this make as a constructor in other class and see what happened. Okay? We should get an error. Let me go to the test singleton, the client class. Okay? What I would do is you can see this test singleton class is not part of the export status over here, right? It's not. So what I would do is go back to test singleton here. I will simply just uncomment this line here. I'm trying to create a new instance of share data. That's what I'm trying to do. Okay? What's going to happen? Well, would it compile? No. If I say compile, it's going to say creation instruction use call to improper feature. Basically, if you expect the error messages, it will tell you in this class, you're not allowed to call that particular constructor, simply because we have declared to be the case over here, data access. Okay, that's one point. And you also have to make sure after this particular feature here, you declare this again. The reason being, you don't want to allow, okay, let me say this. In the client side, when you say creates, okay, we got D1, for example, being data. You cannot say creates D1 dot make. Okay, this will be forbidden. Okay, also, you cannot say anything like D1 dot make. This is also forbidden. This is reason 1 over here, and this is reason 2 over here. Let me ask you a very quick question about iPhone. Okay, what's the difference between these two lines? When I say create D1.make versus D1.make, apparently the discrepancy here just create, right? Yes. Mm-hmm. Okay, good. Okay, let me recap. That's exactly correct. So the first line here, we're basically creating a new object, like a Java new, right? We're creating a new object called D1. And the way we initialize all the attributes for data is by calling the command called make. Okay, we're just creating a new object. The second one, we're assuming that D1 is already an existing object. We're not creating any new one. And then we simply use make to change. Make is supposed to be just a regular command. Just do whatever make will do to the existing objects. So we are not creating any new objects. Okay, that's a difference. But for either one of them, we don't want to allow for the clients. We want to make sure the only way you can actually get access to the data is by data access. Okay? I will get to the expanded in just one moment. We'll get there. Since we learned about expanded only about maybe a week or 2 weeks ago. Okay, we'll get there. And now you can see that under data access over here, I have data just declared to be data. Okay? And now notice that here comes our new keyword once. So that means, what does that mean? If you look at the body of the feature, maybe that makes more sense. If you look at the body over there, creates result.make. What does create result.make do? Well, result is of type data. So create result.make is going to create a new instance of data. Since we declare once, what does that mean? That means we only try to execute create result.make for the very first time. You try to say data for data access. For any subsequent call to the same feature over here, we just return whatever data objects, object data's reference to it in the subsequent call. I'll show you one example in just a moment. Okay, that's what it does. And then what about the invariant here, if that can make sense to you? What does that mean? We have a class invariant here, that's very important here, okay? When I say invariance, data equals data. First of all, is it doing reference equality or object equality? Reference equality, right? Okay, so what are you trying to say here? Anybody try to explain? What does that mean? When I say data equals data, is that always the case, or I can easily make it false?
Always true, because the first time you initialize it set the values accordingly to the.
Okay.
But then the second time we called it's.
Basically like that. Let me visualize that a little bit. Okay. So for the first time, you call data the first time. What you do is, let me just call it R for result, okay? Result is pointing to some data objects over here, okay, like that for the very first time. What about the second time? Second time, you can think about, you just create a new reference, like a reference copy and return it, right? Maybe R2, the second time. What about third time? Basically just another reference copy, R3. So now I'm saying that for any consecutive call R3 and R2, they are really referring to the same objects. That's what the invariant is trying to say. Question for you. would it be okay if I simply say data, tilde, data? Let's make some assumption here, okay? I want to be precise. Let's assume that we also redefine the is equal for data. Let's say we already did that, okay? Let's assume that's the case. If I simply say data, tilde data as an invariance, would it work? Why would it not work? Yeah, actually, in some way, if you say data is equal to data, you're only requiring that at in the invariant level that the contents of any subsequent call to the data to be contents to be the same. You're not being strict to say the reference should be the same as well. So that's not good enough. Okay, for example, let me give you a very common wrong implementation. Okay, if I hypothetically change this just to do. Okay, now, if I change it to do, would it still pass this invariant here? No? Yes? No, right? Because for the very first time, you call this data here, it's going to create a new data object. For the second time, since it's not once, you will execute the same body again, just another object. So they are of different references. Of course, you say data equals data will give you different references. On the other hand, before I take a question, okay? Let's say I still keep the do over here. Would this invariance be okay? Would it violate it? That would be okay. Exactly, we're comparing contents, right? So in some way, we are not really comparing the references anymore. So do think about these combinations over here, right? They could be on the midterm. They could be. May not be, but could be. Yes, question?
So how is the create result.make different from create data.make?
Can you put your question again? Yeah.
So instead of saying result.make,
Yeah.
can we say data.make?
Data.make. I see what you mean. So the answer is no. Okay, it's a good question. The question was, can I simply do the following? Let's say for the data query over here, I say, okay, data over here, return data. Okay, and then let's say we simply say do. Okay, the question was, rather than saying create result, I simply say creates data. Dot make. Would it work? It's a good question. I like it. Okay. Would it work? Yeah, over there on the right hand side. So rather than saying create result.make, I say create data.make. Would it work? Well, actually, I got it. Well, I'm pretty sure I'm right. I don't think this will even compile, because usually the reason. Huh? Yeah, first of all, why would it not compile? Let's get it straight. Okay, yeah, I heard something like, okay, it's a query name, right? Because the reason is, you can see the data over here. Data is not a variable name. Data is a name for the query. You cannot say, I want to create a new query, right? That's why it doesn't work. Okay, that's one flaw, okay? Make sure you don't do it, okay? And the second flaw is, every time when you're trying to do a query for IFO, I know it's very different from Java. Java just say return. But in IFO, you always have to make sure you assign something to the result. Okay, just don't forget. Okay, but anyway, if you do this, it's not going to work. Okay, guys, any questions about the Singleton pattern? Before I show you the client code, we'll go over that. Yes?
Where's the result coming from? Which result are we trying to make?
The result, well, you can see that over here, right? Let me just highlight it. You can see, let me just use a different color. You can see data returns a data, right? So that's a return type. So that means the result, which is a keyword, is of type data. Okay, that's why. Okay, any more questions? Yes. Yes, the question was, why was the invariant not data equals data? Okay, we only talk about all expressions for the post condition, because it's immediately after you execute a particular feature, we want to draw a connection between the pre-states, which is old, and also the post states. For the invariant, it's not really for that kind of purpose. Invariant is simply for stating some global property, right? You don't really talk about the difference between pre-state and post-state, not really. Just talk about global property. No, that's not the case. The data over here, you see, maybe what you're confused about is this. When I say data on the left-hand side, okay, data on the left-hand side, it's a call to query data, right? Data is not an attribute. Data is a query, right? Data is not an attribute, it's a query, right? And the data over here is simply a separate call to the same query called data. If you simply do it wrongly, you simply say do. You're going to execute the body twice and then create two different data objects, right? Yeah, if data was an attribute, but that's kind of irrelevant to our discussion here, right? Good. Okay, guys, any more questions about supplier? Okay, it's good to get this straight. And then the bank example will be just like this. Okay? Okay, let's have a look at the client code, and then hopefully that will clarify even more confusion. Okay, this is a client code. I should call it test. Okay, and then let's say we declare some data access over here. Also, we got two data and data. Since we want to test the singleton pattern, of course, make sure you change this back to once. Okay, of course, not do. Okay, make sure you change that back to once. So we want to make sure D1 and D2, the only way we can get D1 and D2, which is of type data, is via the data access. But how do we do that? Let's see how we can do it. What we can do is, first of all, you can see D1 and D2. Okay, and there you can see, let me just use a different color, and there's a reason for that. The first one, I'm going to say D1 is access.data. And the second one, let's say over here, access.data, the same call. And I have a question for you. The green and the blue, right? Is the way we get the data from the access the same between green and blue? Given that we have a once over here. The same way or different way? Okay, how is it going to be different? Let's say for D1, exactly what's going to happen is, well, how is it going to happen? So let's say, let me talk about this line here. Okay, sorry. Let me just get rid of this. And okay, let's talk about this line first. Access.data. That's the very first time I call this once feature. Agree? The very first time. That means I'm going to execute the body of this feature over here for the very first time and for all. Okay, that means for here, I'm going to create some data objects over here. I'll just call it R for the result. Okay, that's for the very first time. What about the second time? For the second time, we're also going to execute this particular feature here, but the problem is, it's once, right? That means it's the second time, there's some global counter like how we did for the Java. So that means we're not going to execute this anymore. We simply just create, let's say R2 is just pointing to data. And then we let D2 also point to this particular object. So they're just aliasing. Okay? That's how the singleton pattern works. Okay? So now if you do some checks over here, so now after all these D1 and D2, they point to the same objects. Okay? So D1 over here and D2, just aliasing. So now if I do D1 equals D2, true, right? According to the invariance, any subsequent call to the same data feature or query should return the same objects. Okay? And D1.v, oh, by the way, so since we are trying to set it, you can see the default value for the v will be just 10. I'll put 10 here. Okay, I forgot to put it. Okay, for the very first time. So now D1.v will be 10. D2.v, just the same objects, also 10. So this is okay. So now let's do one exercise here. If I say I want to do D1.change v 15, right? So now here over here the context object is D1. I'm saying I'm using D1. Look up where the data object is. It is exactly this data object here. I want to change its value to be 15. Well, change that to 15. So So now if I say D1 equals D2, would that still be true? Of course. D1 and D2, D1 and D2 still refer to the same objects. What about D1.V equals 15? True, right? D1 refer to this object over here. Of course, it's 15. D2.V, this is more important because it's aliasing, right? Singleton pattern just give you lots of reference copies, basically, for the same objects. And now D2.V, of course, B2 also refer to the same object. That's also 15. Okay, that's about singleton pattern. Questions?
Oh, just one question, Professor. How does this expanded class play a role?
Oh yeah, I forgot to mention. Yes, expanded class. Good. Thank you for reminding. I just forgot. Now, I have a question for you. Okay? Did you notice one thing? Okay, let me ask you this. Okay? Thank you for mentioning it. I just forgot. Okay, very good. Now, look at that. I got access over here, and access was declared as a local variable. Why would it even compile? Because remember, usually when you declare some local variable there, let's say a string, and then as a first line, say that string.append. IFO compiler will complain due to voice safety to say target might be void. So why is there's no such error for saying access might be void? Yeah, it's expanded type, right? That's the reason. Remember what we said about expanded class before? As soon as you declare that, it's going to be initialized automatically. You don't have to explicitly create that. That's why we're using expanded here, just to save some line. Okay? Guys, we okay for this? Okay, I'm kind of trying to work backwards for you, right? Okay, good. Okay, if no questions, I'm gonna go, let me just go over the diagram for you. Okay, so far we have seen the architecture diagram for testing the post condition. We have seen the architecture diagram for iterated pattern. So this is the third one. Also, we learn by examples, okay? Basically, every time you do your bound diagram, you have to include some clusters or packages. You gotta include some client supplier. Also, you gotta include some inheritance if applicable, right? So these are the ingredients for your bound diagram, okay? So let's just have a quick look. The only thing that's new, as we which didn't exist in the iterated pattern, is like this. Okay, let me use a different color here. Okay, notice how we draw the arrow over here. It's basically a double line arrow with a vertical bar above, right? This, no surprising, is basically for expanded type. Okay, we are saying that client number one declare data access, and the data access itself is expanded, not referenced. That is why we can simply go access.data by just declaring it. We don't have to initialize it. Okay, that's a diagram detail. Okay, so that means expanded, and then again double line arrow means client supplier. Okay, and then we also got data over here. So from data access to data, right? Because if you see over here, data access over here, we do have a data feature here of type data, right? That's how we get a client-supplier relation, okay? Yep, so hopefully that's straightforward to you, and we're using the ones, and also the invariant over here, as I explained. And then, in general, the data might support some value over here, interest rate, exchange rate, and also support some command for modifying the value. So that's the general pattern for singleton. And they belong to different packages or clusters. Okay, any question about the architecture diagram here? The only thing that's new is about how you draw the arrow for expanded. Okay, we will see some case study for singleton pattern as we do lab number 3 and projects. We'll get there. Okay. Okay, after this, I would like to just do one more example very quickly. So now let's revisit what we had for the bank, right? Basically, you will see that the structure is exactly identical. Let me highlight it to you very quickly, and then we are done for the singleton, and then we'll go to inheritance. First of all, let's see this over here. We have, let me be consistent over here. We have bank data, okay? And then bank data can only be created inside the context of the bank data access, right? That's why you got bank data access over here, right? Because of export status. Okay, that's one thing. And also, because it's expanded, So that's why you can just declare the data, you can just declare data access to be a local variable and you can use it right away. Okay? Yeah, the same structure, like this small example. Okay, I already made the source code available to you, so check it out if you still got doubts, and feel free to change to test by yourself. I'll suggest the following exercise. What if this is do? What if, do the following exercise. Rather than once, try do. Okay? Over here, rather than equals, try tilde. And try the 4 different combinations and see what happened. Okay? Yes.
Professor, how does the feature export function work again?
Sure. Basically, feature export is very easy, like this. So again, it goes curly brackets like this, and inside I'm saying that this is the only allowable client class for using the make as a creation procedure, which means only bank data class, only bank data access class can try to do creates bank data, which is exactly what you're trying to do over here. Okay, that's one thing. Okay, that means if I try to do the following, let's say over here in the client side, if I try to say creates data dot make, as I also illustrate in the iPhone Studio, this will not compile simply because account is not one of the list in this export status. Okay? Yeah.
Can you have multiple classes in the future?
Yes, the question is, can you have multiple classes in the export status clause? Yes, you can. Yes, you may.
Like just separated by comma?
Exactly, separated by comma. Yeah. Yes.
Can we declare an object for bank data class?
Can you mean in where? Can you mean in the account class?
Or client side.
Okay, let me get you make sure I get your question correctly. You're saying, can we declare an object of type data? Of type bank data? Well, of course you can. Well, you can see this is exactly that, right?
You just said that only bank data access can create
Oh, yes. Okay, it's different. Okay, we are talking about declaration. So here I'm only declaring the data, right? But to initialize it, I don't necessarily have to say creates that particular data. I don't have to. I'm doing that implicitly. The way I do it is by saying data access.data, which will return to me the singleton reference. That's how the way we get a reference is indirect, not directly. Yeah. Okay, good question. I like that. Good. Guys, any other questions about singleton before I move on to a new topic?
Quick question, Professor, for expanded, is it optional? Can you leave it out?
Yeah, so the question is the expanded over here optional? I would say yes, it is optional. But you gotta be careful. If you take out expanded over here, your code as is will stop to compile, simply because you declare data access over here as a reference type because I got rid of the expanded, right? So that means data access now must be explicitly initialized. I would say if you use the singleton pattern in many classes, if many classes must get, let me put it this way. If there are many classes which needs to get access to the shared data, that means you're gonna say local declare, and then you're gonna say create that local variable explicitly every time. That could be quite annoying. So that's why we put expanded. Yeah, but you can definitely do it. That's fine. Okay, any more questions about singleton pattern before I move on? Okay, we still have about 15 minutes or so. Why don't we do some inheritance? What I will try to do is, first, over here, there's some testing of the singleton pattern here. I'll let you go over that. The way I set it up is just like how we do the simple example, okay? The only 2 lines I want you to think about is, look at this line over here. Okay, I'll make a comment for you. You can I can reaffirm that's the case. ACC.make, okay, ACC1.make. I think what I meant to do, yes, ACC1.make. This is going to be the first time this particular data in data access is called for the very first time. Okay, I want you to reaffirm that for me very easily. Okay, and this line where we are trying to create a second account, this is going to be the second time. And notice that we got once over here. So I want you to see the effects, exactly how we illustrate it in the simple example. Okay, let's now go to inheritance. Okay. So this is my plan. I know you learned about inheritance back in 2030. So for those of you who did not take 2030 with me, maybe quite many of you, I can recognize the faces, right? So I would say you may not have learned polymorphism, dynamic binding in a very systematic manner. That's my presumption here. Okay. So what I will try to do is, I'll mostly just remind you about why we need inheritance for code reuse. This part, I'm pretty sure you know very well. I just remind you very quickly about IFO syntax and why code reuse can be nice. And also, without inheritance, I will use that to introduce the single choice principle. Okay, that's also a design principle we want to obey. After that, that will only take about 15 or 20 minutes. And then for Wednesday and possibly after the reading week, I will give you a very systematic review or introduction, if you haven't learned it properly before, about polymorphism and dynamic binding. That's what I will do. Okay, maybe maximum 1 or 2 classes, okay, to make sure everybody is on the same page. Because many of the design patterns that we're going to talk about later depend on polymorphism and dynamic binding. That's why I want to make sure everybody's okay. Okay? But we'll see some example in just a moment. Okay, let me just tell you the overall picture. Okay, there are different aspects for inheritance. Okay, the most obvious one as a programmer is about reusing the code, because when you inherit from a certain class, you're basically inheriting all the code from that particular class. You are reusing the code without duplicating them. So that's a code reuse part. For this part, you learn very well from the 2030 or 2011. Okay. Now, the second part is more about behavioral aspect. There's something called substitutability. For this one, I will definitely address in details. But there are 2 parts to it. Okay? One is more from a typing perspective, just about polymorphism and dynamic binding. If I declare a variable at the compile time, would it really compile if I do certain assignments? There's some typing rules I would like you to know. Okay? And dynamic binding simply means if I try to make a particular method call, depending on what the dynamic type is for this context objects, it is going to call the correct version. Okay, that's something about dynamic binding. We'll go there too. Now, for these 2, you learn more or less in the previous Java course. But the third one is something that's really important: subcontracting. Okay, so let's say this: if I say I got a person class, I also got a student class. A student is a subclass of person, right? Whatever a person is expected to achieve, a student, being a subclass, must be able to achieve it as well, right? We obliged to achieve as well. So that's something we'll like to use contract to enforce, right? So since we learned about precondition, postcondition, class invariance, so we want to see exactly what's the consequence if you declare contracts in the parent class. How is that going to affect the child class? Okay, that's going to be new bits compared with the previous courses. Okay, so that's more like a runtime checks, but we'll get there. So today I'll mainly just do code reuse and possibly do some very quick example if you have time. But on Thursday I'll definitely do polymorphism and dynamic binding. Okay, maybe after reading week we'll do subcontracting. Okay, okay, let's just see this motivating example. For those of you who took 2030 with me, just take this as a review. But for those of you who are not, just take it as a new example. Okay? I want you to spend just maybe about 2 minutes. Just read through this problem description here. That's going to be the problem we're going to use for the rest of the lecture and for the future classes for inheritance. Okay? Look at that, and then think to yourself, since all of you are very good Java programmers, I presume, so you should know how to solve this in inheritance. Okay? Think about it, okay, just for 2 minutes. Sketch some solution in your mind. Okay, just 2 minutes. Okay, let's take another 30 seconds, and then we'll see how we can solve it without inheritance, in which case I will introduce something called single choice principle. Okay. Okay, everybody is okay? Okay, basically we got students, we got non-resident student, we got resident students, discount rate, premium rates. We can register, we can also calculate tuition, right? Exactly what I highlighted. Okay. Let's see how we can solve it without inheritance. Let's go over that quickly, and then we can also see how things can be implemented in iPhone quickly. So the syntax could be useful for later. Okay, so now let's say we got a course class in iPhone. Okay, over here, let's see here. We have a class called course, and then the only constructor we have is make. We have title, we have fee, and also we have a constructor here, the command, and we can initialize the title and also the fee for the course, right? Okay, nothing surprising here. Okay, let's have a look at over here, resident students. So we got three classes here. We got course, we got resident students, we got non-resident students. So these are the three classes. Let's have a look at the resident students, right? Again, we got a constructor for resident students. Let's say over here, every student has a name, has the list of courses they're registered into, and also in the case of resident students, we got premium rates, okay? Also, we got constructor for the student, which will initialize just the name of the students given, and also create empty register courses. And then, in the case of resident students, we can set their premium rates, not discount rate, premium rate. Okay, set the premium rate to be a certain amount, and also we can register for the course. And notice that the way you register courses for students does not depend on the type of students. The way you register for resident students, the way you register for non-resident students is just the same. Okay? So now we say courses that extend the course. So now, and then we have some queries over here. How would you calculate the tuition for resident students? Well, yes?
Base plus the premium?
Base plus the premium, I like it, but the thing is you also need a loop, right, to calculate exactly what's the base, right? Good. Actually, not base plus premium, base times premium. It's a rate, right? It's not just additional amount, but that's good. Okay, we've got a base over here, and then we can simply do across the courses, which is linked list, and then simply calculate the base based on the courses you have registered so far. And then after that, we can say result is assigned to, again, you can see we're using result here, right? We're not using tuition, right? Result is assigned to base multiplied by premium rate. Okay, very simple class. Nothing surprising here. Now, apparently I'm not using inheritance here, right? Question for you. How would I do it without inheritance for non-resident students? Would it be very similar to resident students?
Make another class.
I gotta make another class, right? So what would be the difference really? Difference. Let's talk about difference. You want to say something? Yes, at the back. Never mind. Okay.
Instead of premium, we had something else for
Yep. So basically, exactly that was the yellow highlight, right? So basically, I'm going to say, well, if I want to create non-resident students, I'm going to change resident student into non-resident students. I'll change premium rate into discount rate. I'll change set PR into set DR, discount rate. I'll change premium rate multiplication there to multiply discount rate. That's exactly what I would do. Everything else is just the same. Duplicates, right? Exactly. Good. I wouldn't bother you too much, but I'll just show you, and then I will illustrate single choice principle. Basically, you can see that everything that's not yellow highlighted, they are duplicates. Whenever you got duplicates for your design or code, it's not good. It's not a good sign. It violates something called single choice principle, okay, which I will illustrate. So now you can, here is the intuition, right? The parts that are duplicated may change at some point later. For example, if you can see that, I'm just give you one example. Okay? So let's keep these two classes in mind. Let me ask you the following question. I'll go to the test in just a moment. Okay, I will go directly to. Okay, duplicate is not good. So it's, let me just say this. I'll go to the single choice principle definition just in a moment, but let's see this. Let's say I want to change the way we do register. Used to be just extend the course to the end of the students' register courses. But now let's say I do want to do some check over here to say if the courses that count larger than or equal to maximum capacity, I don't do anything. Maybe do some precondition check or just set some error flag, whatever. Otherwise, I'll do the courses extension. Let's say this is a policy change for the register. So now, if I go back to my code, which I will show you on the iPad to make it very obvious. Right? So these are the two classes, right? With a lot of duplication, right? So now let's say I want to have a change on the register method. There's a change happening. Is there a single place I can change? Right? It's not actually more than a single place, right? There are multiple places. So you can see that over here, the register method over here, I need to, let me use a different color, that might look a little bit better. I need to change the register method over here. Somehow, I also have to change this register method here as well. Two places. It's simply because I only got two classes for the students. I got two kinds of students. What about I got 10 kinds of students? I need to change 10 different places, right? To be the new register method. Yes, question?
Why don't you have attribute which states whether the student is a resident or non-resident, and then you can make the tuition like take in a rate, and depending on whether the student is resident or non-resident, you can take in a rate.
Okay, the problem you're not suggesting something relevant to the register. You're just talking about tuition calculation, right? The problem is, what about I have 5 different kinds of students? How many Boolean variables do you need? How do you distinguish between them? And also, we want to, maybe as we go later, okay, let me just recap your point so the rest of the class can benefit from that. There was one suggestion here to say, why don't we simply, let's say there's a single class called students, something like that. Only a single class. And then we simply got a Boolean attribute, let's say, I would say residence or not, Boolean. So whenever I create a student object here, I'll set it to be true if it is a resident student. I'll set it to be false if there's non-resident students. Now, of course, if I want to calculate tuition, I can do it accordingly. The problem is this mechanism does not scale up, right? The problem is, let's say we got 50 different kinds of students or 50 different kinds of objects we're dealing with. In that case, how can you make a single Boolean or make some simple type to distinguish between them? You'd rather manage this kind of different kinds of objects issue at the runtime automatically. Okay, that's why we got inheritance. Okay, good. Okay, guys, let's not lose the focus here, but I'll keep it here just in case you want to look at that. So it's about single choice principle. Single choice principle tells us that if we want to change the register method or feature to be something like this, to do some additional check, we have to do this change in here and in here. That's multiple places. The more classes we have like this, the more places we have to change. So that's really hard to manage. Okay? So to really satisfy single choice principle, we want to make sure the register method, which is common to all different kinds of students, we want to put it in a single place. So there's only one single place to change later. Okay? Any question about this? Okay, that's about single choice principle. Is it clear or we're okay, right? Okay, if you go back here, okay, so single choice principle is like this. So when there's a change needed, so there should be only a single place or a minimal number of places. I would say in principle just single. But sometimes you may find good reason to have multiple places. But as long as you can argue that it's minimized, that's fine. Where you should make the change. Okay? So one example is just about a register method, but there's another example here. It's also about a tuition. Let's say we want to, somehow calculate to include the inflation rates, just another concern. So that means we also have to change the tuition here and also the tuition here. Also multiple places we have to change. Oh, sorry about that. Wrong thing. We got to change the tuition here. Also got to change the tuition here. So these are the multiple places we have to change. So later on for your projects, I will actually ask you to explain how your software design will satisfy the single choice principle, right? That's really something you want to argue that is a good design. You want to minimize duplicates in your code or in your design. Okay, how about just 2 more minutes and then we can call it a day. Okay, that's about it. Violation of single choice principle. Okay, so this is something that's also crucial. Without the inheritance, how do we manage all the students together, right? It seems like because resident students and non-resident students have nothing to do with each other. They're just separate classes. So the way we can manage them is by declaring separate collection of them, right? So we have one collection for resident students. We have one collection for non-resident students, different. So that's why you have to have so many data structures to manage. Okay, you can read through the code. That's really about the disadvantages for using a solution without inheritance. Okay, what I will do in just 1 minute is to go over how the code with inheritance looks like. Just a few keywords to introduce for IFO. And then for the coming Thursday, I'll talk about polymorphism, dynamic binding, the more interesting stuff. Let's do it quickly, just 1 minute. Okay, that's the inheritance hierarchy. Create a new class called students with all the common code, and then 2 subclasses. Okay, and you know that we should just say student is a superclass. All the common things about between the 2 kinds of student will be here. Name, courses, constructor, register, and also tuition. Which means later on, if we want to change the way we register, only come to the register method here, only a single place. So that's a single choice principle. Okay? Okay, now let's see how we do inheritance. So you can simply say inherits student. You have seen this a lot. Okay? And then you just do also gotta say redefine the tuition because I'm gonna use the premium rate for resident students. Okay, premium rate is something that's additional for this particular resident students and also set premium rates. So these are the additional features. And also we got tuition here. So now one thing I want to show you is precursor. Okay? So now precursor here is like calling the version of tuition in the superclass. Because in the superclass, the tuition is a query returning real. So I can simply use precursor here as a real. Get whatever the calculation result is from the superclass as a base, and then apply the premium rates. That's how you can use precursor, like a super in Java. Similarly, you can do the same thing for non-resident students, and then you can also apply for precursor. Okay? Okay, so far? Okay. So now what I would like you to do is go over the code very quickly, especially get familiar with the features for student, resident student, non-resident students before Thursday, and then we'll go from there. Okay?